I forget how many times I say this, but this really is one of my favourite areas of maths. Let's start off by looking at long division with numbers. So we would write this down as 12s into 4,188. And we would start off and we'd think, how many 12s fit in 4? No, how many 12s fit in 41? Yep, 12s in 41 goes 3 times. Or really, what we're saying here is that 300 times by 12 would give us 3,600. And that's the greatest number of hundreds of 12s that exist here. I subtract these away, and I'm left with a little bit of borrowing. 11 take away 6 gives me 5. And I continue. How many 12s in 58? Well, that's going to go 4 times, or actually, this is the tens column, so that's 40 times. 40 multiplied by 12 would give me 480. Subtract that, and I'm left with 108. 12 into 108 goes 9 times. Multiply 12 by 9 is going to give me 108. Subtract that, and I see I've got no remainder. So the answer to this question is 349. Now let's go ahead and use that with polynomials. So here I want to see how many lots of x plus 4 fits into 3x cubed plus 11x squared minus 2x plus 8. Forget this term to start with. We're just thinking how many x's go into 3x cubed. X's into 3x cubed goes 3x squared times. Notice how I keep my quadratic terms together. Now, I'm multiplying 3x squared by everything here, which is going to give me 3x cubed plus 12x. Now, just like with our long division, we subtract and see what we've got left over. 11 take away 12 is going to leave me with minus x squareds minus 2x. I'm just dropping the next term down. And I repeat. How many x's go into negative x squared? Negative x. Multiply negative x by all of this, I get negative x squared, negative 4x. And do my subtraction. This time, negative 2, take away negative 4, that's going to give me positive 2x. And again, drop the next term down for me. X's into 2x goes 2 times. Multiply everything by 2, and I've got 2x plus 8. Subtract, and I've got no remainder. So, 3x cubed plus 11x squared minus 2x plus 8 divided by x plus 4 is equal to this top line, 3x squared minus x plus 2. Another way of stating this would simply be to say that 3x cubed plus 11x squared minus 2x plus 8 is equal to x plus 4 times by 3x squared minus x plus 2. In this example, we have an x to the power of 4, no cubic terms, no quadratic terms, no linear terms, but what we want to exemplify here is how we should always lay our work out. There's my x to the power of 4. I haven't got cubic terms, I haven't got quadratic terms, I haven't got linear terms, I've then just got this negative 1 at the end, but I always leave space for these. X's into x to the power of 4 goes x cubed times. X cubed multiplied across gives me x to the power of 4 minus x cubed. Subtract. Well, these cancel, and what I've really got here is 0 take away negative x cubed, which is going to give me positive x cubed. Repeat. X's into x cubed goes x squared times, I write it in my squared column, multiply by x squared, I've got x cubed minus x squared, and again subtract. I haven't got anything here, this is still a 0, so this then becomes x squared. X's into x squared goes x times, multiply by x, I've got x squared minus x, subtract, and I'm left with x. Now I do have this negative 1. What do I need to multiply by this time? Well, plus 1. And I've got here x minus 1. So again, I've got a situation where I've got no remainder. So x to the power of 4 minus 1 divided by x minus 1 is x cubed plus x squared plus x plus 1. Final example, same setup, 2x plus 1, 4x cubed, 4x squared, 3x minus 1. 2x's into 4x cubed is 2x squared times. That's going to give me 4x cubed plus 2x squareds. Subtract leaves me with 2x squareds. 2x's into 2x squared goes x times. So now I'm multiplying all of this by x. That's 2x squared plus x. Drop this term down. Subtract. Cancel 2x. Drop down my next term. 2x's into 2x. Well, that's 1. Multiply by 1 and I've got 2x plus 1. Subtract. Oh dear. Well, not oh dear. We're not always going to get a situation where we have a remainder of 0. Sometimes we do have remainders. The question is, how do we express this? So, what we've talked about here is doing 4x cubed plus 4x squared plus 3x minus 1 divided by 2x plus 1. And what we're saying is, the result will be 2x squared plus x plus 1, but then I've got this remainder. I've got a remainder of minus 2, which is yet to be divided by 2x plus 1. And that is how we deal with a remainder.